Welcome back to .NET Rocks. This is Carl Franklin.
And this is Richard Campbell.
And we've been holding out in our respective corners of North America. How are you doing, sir?
Home is good, right? Hard to be unhappy about home.
Yeah.
Do you remember the gig that fits up your nose?
Yeah. It was a 1 gigabyte USB key. And we were so amazed that it was 1 gigabyte back then.
At that time, I think it was 2005.
Yeah, I think you're right.
It was the original road trip, and
Yeah.
I'd scored it from someplace in Malaysia.
Right, yeah, some big mall or something.
Yeah, and it was maybe the size of your thumbnail.
Right.
So it was smaller than a regular USB key, and it was a gig. That was kind of a big deal. So in the Best Buy yesterday, bought a 128 gig USB stick that is like a quarter the size of that.
What?
Like, it's literally the USB connector is 3 times the size of the rest of it.
Oh, my.
It's at the limit where you can actually get your fingers around it when it's plugged in. It's ridiculous.
Oh, man.
And I swear it was $20.
Well, I think that's the better know framework right there. We don't even need to roll the music, man.
Sorry.
No, I think that's great. 128 gigs for $20 at Best Buy. Go get it, man.
Yeah, and just tiny. Oh, and by the way, they still had room in that tiny little thing to put an LED in it.
Oh, wow.
So that when you're copying files, it's blinking away. But otherwise, you'd forget you had it because it's just the size of the USB port. Like it's be gone.
Fantastic.
It's crazy. And I'm sure there's bigger ones. But that one was on the shelf and it was trivial.
Wow. All right. Well, I'm going to save what I was going to say for the next show.
Fine, be like that.
Yeah, because that was good.
Should we just play people the music?
Let's play the music anyway. Okay. Go ahead. Stupid, crazy music.
I know that music deep down annoys you because, but people love it. People sing it to you.
I know.
What's up with that?
I don't know.
Anyway,
no, there isn't a
that's
complete
what I
version.
got. That's what you got. That's what we got.
So who's talking to us, Richard?
Grabbed a comment off of Mr. Seamann's last show. That was 14/18, February of 2017, when we talked about Conway's Law. Of course, Conway's Law focused on how organizational structures reflect what they make. You know, the point being, if you have 3 dev teams working on a product, you're going to end up with 3 feature groups.
Right.
That's what tends to happen. Got lots of comments on the show, as per normal. This one's great. This is Simon Timms' comment. By the way, Simon is a regular contributor to Humanitarian Toolbox, although I figured that out after I'd picked the comment already as one I wanted to put on the show. But thanks for your contribution, Simon, he says, I found myself violently gesturing at the stereo in my car as I listened to this episode, which is good because yelling at the stereo is kind of silly.
It is a little silly.
Isn't it dangerous when you're driving, though? Gesturing, I mean...
Only if you take your eyes off the road.
He didn't say what he's gesturing with.
Right. Fair enough.
I'll leave that sitting there. You can look at it, at your leisure.
Yeah.
The whole discussion really hit home with some of the team design challenges on my current project. We have an application which is layered, much like the teams who write it. Communication inside a team flows much more easily than through team boundaries, so having software which reflects that is only logical.
Yeah.
Great episode. Keep them coming.
It was brilliant.
It was a great episode, and he's back, so more greatness. Simon, thank you so much for your comment. We are violently gesturing at you right now.
I'm waving.
I'm not saying what with. We're just violently gesturing. And a copy of Music to Code By is on its way to you. And if you'd like a copy of Music to Code By, write a comment on the website at .netrocks.com or via any of our social media, because we publish every show to Google Plus and Facebook. And if you comment there and we read it on the show, we'll send you a copy too.
And definitely follow us on Twitter. He's at Rich Campbell. I'm at Carl Franklin. Send us a tweet. Apparently, they all fit up Richard's nose.
Yeah, I've sort of thought about the old gig up the nose thing. It had more to do with the size of my nose than the size of that gig.
Oh, and by the way, Music to Code By has 2 new tracks now. So
congratulations, dude. So was that 14 and 15?
Yeah, so 15 tracks, and the whole collection is now at, I think, a whopping $43. So it's still a great deal.
Yeah. Lots of stuff. And we give it away every show.
That's right. Now let's bring on Mark Seemann. He was the voice that you heard there while we were trying to be funny. Mark helps programmers make code easier to maintain. His professional interests include functional programming, object-oriented development, software architecture, and software development in general. Apart from writing a book about dependency injection, he's also created several Pluralsight courses, videos for clean coders, and written numerous articles and blog posts about programming. He's an independent consultant, author, and conference speaker living in Copenhagen, Denmark. Welcome back, Mark Seemann. Speaking of Music to Code By, you were the guy who inspired me to do that.
Well, thank you for having me again, and I'm happy that I could inspire someone at least. so that's one person.
Richard's comment that he read reminded me about that show, and I hadn't really thought about it until back then, but man, that's just a brilliant observation.
Right. We were talking about, among us other things back then, we were talking about flow, this mental state where you sort of forget about, the time and, the time just flies by. And, that's a thing that programmers actually experience quite a lot. Yeah. And that's probably one of the things that we might talk about, in the next hour or so.
That was episode 1001. That's how long that was.
Wow. Huh. Wow. Well, the observation of software representing the organizations that build it is another one of these fascinating observations. And that I was stunned. I hadn't thought about that until Richard read the comment too. It's just fascinating.
Oh yeah, so you tend to forget about those things until they sort of pop up, but then once you start seeing them, you just see it everywhere.
You can't unsee it.
Basically, that's some of the other comments that you see there on that show is that people start to see them everywhere once you start looking for them.
Right.
Yeah, so that reminds me of another thing that I've been I'm a regular listener to your show as well, and I was thinking about something that repeatedly strikes me when I listen to your show. How many people who actually talk about various sorts of constraints that you can actually apply to your process in various ways. So one episode that I'm reminded of was with Il Waters, who talked about how making websites accessible for people who have all sorts of or various sorts of impairments, and she talks about how making a website accessible actually turns out to make it better overall, because not only are you targeting those particular people who may have difficulty seeing as a normal person or with a normal eyesight and so on, but it actually makes it much more useful to other people as well.
Right.
And I think that's a pretty interesting observation that adding an extra constraint actually makes something better. So that's something that I've been, looking out for the last couple of years, looking for all sorts of constraints and how they make things better.
And we did a show with you on constraints in C#, I think, and how just applying them would make you a better programmer.
So we did a show, I think we called it Less is More, which was basically about the constraints that you can apply to various sorts of programming language features, and saying, what if your programming language didn't have that particular feature? What would happen then? So that's one of the episodes that we did as well.
Yeah.
But I think so. Yeah, just stop me if I'm rambling here.
No, not at all. We want to hear the rambling, please.
Yeah. Okay. Fair enough. So what I've been thinking about is that there's a lot of constraints that actually turns out that if you start to apply those, things become better or easier in various ways. And this is an idea that goes back thousands of years. I don't know if you've ever thought about why is if you take all sorts of epic stories like the ancient Greek stories like the Iliad and the Odyssey, for example, and there's the Indian epics as well. All of those are basically in lyrical form. They're on verse. So if you take the Iliad, for example, it starts something like what's it? Depending on your translation, it's something like "Rage, goddess, sing the rage of Peleus' son Achilles," and stuff like that. And why is it the fact that why are all those things in verse instead of just prose as you'd normally write a story today? And I think as far as I've understood from people who've been studying those things is that these stories actually predate written text. So so these were actually oral tradition. So if you have to tell a story like the Odyssey or the Iliad, which is like if you print it in a book, it's like 500-600 pages.
Right.
You can't just remember that by heart. But by imposing some sort of structure, so saying, well, every verse has to have a particular rhythm, and maybe you even have to have some rhymes in, within those verses, you make it easier to remember. So the constraint actually makes it, easier to remember the entire, how the entire story actually flows.
Right.
Yeah, it's the power of lyricism. It's something about the way your brain records lyrics that's different from just spoken word.
Right. So it helps you to remember, because if you're the bard who's telling the story, again, you're sort of going like, okay, so what was the next verse? Oh, it was something that has to rhyme on, blah, blah, blah.
Right.
And then you sort of figure it out as you go along. So you see that stuff happening, over and over. And, so I live in Denmark, and there's been a couple of examples in Danish culture in the last 20 years that actually have really emphasized this as well. There was a wave of cinema called the Dogma 95, which started back in 1995, hence the name, where some movie directors sat down and decided to make a very specific set of constraints, and then they had to go and make movies based on that constraint. And what actually turned out that these were people like Lars von Trier, for example, and a couple of other people who actually went on to win various prizes on the Cannes Film Festival. So probably not something that most American audiences would know a lot about, but it's actually a pretty big deal in Europe.
Well, you see instances of this happening in other mediums too, like, those cooking competitions where you get some crazy ingredients like licorice and frog's legs that you actually have to make something out of.
Yeah. That was actually the next example that I wanted to pull out, because we also have this thing called the New Nordic Cuisine, which means, it's sort of semi-French, meaning the New Nordic way of cooking, if you will. And the idea here, again, is that you can only use more or less local, ingredients. And when you have that constraint of only having to, only being able to use local ingredients, and if you're in Denmark or Norway or in Sweden, that's actually a pretty harsh constraint, because that means you can't use tomatoes, you can't use oranges or lemons, or you can't even use chocolate in your desserts and so on. So you have to figure out what to do instead. So that again turned out to produce one of the most famous restaurants in the world called Noma, which is right here in Copenhagen, because they did impose that constraint. So creating a constraint actually gives you a lot of it might actually spark a lot of creativity.
Let me press against the constraint aspect and look at it a slightly different way. And I think back to what Elle was talking about with making user interfaces more usable for folks that see and hear differently. How much of the benefit comes from the scrutiny rather than the actual constraint? That because we focus on it to work within a constraint, we simply do a better job. UI is often emergent. You just sort of do, these are the things that need to be there. Close enough. Where just the consideration of usability in general makes things better. Right. So I'm not a UX expert at all, but I think one of the things that probably happens there is that, as you said, Richard, the fact that you have the constraint forces you to consider things that you may not have, otherwise considered. Right. So fair enough. Let's bring this back to programming. So if I may, though, let's start at a very basic level. I would point out I did pull the first stanza of the Iliad. So if you'd like it, I'll happily read it. It is beautiful in its own way. It is harsh.
Yeah, go ahead.
Sing, goddess, Achilles' rage, black and murderous, that cost the Greeks incalculable pain, pitched countless souls of heroes into Hades' dark, and left their bodies to rot as feasts for dogs and birds, as Zeus's will was done.
Heavy stuff, man.
And of course, originally written in Greek, so I wonder how different it would sound. But it's a rage. They're furious at what has happened. It's a poem. I know it's a book, but it's a poem.
It's a very long poem.
Getting back to your comment, Richard, about the constraints and then, how you think about them, I would say that the constraints have to be there in order for you to think about them. True. So first come the constraints and then comes what you do with them. And what you do with them obviously is what results in better software.
Yeah, and so maybe the point is moot. You have to do both.
but that's one type of constraint where the constraints force you to think about things. But there's another type of constraint that relieves the need for thinking about things. Mm-hmm. So let me ask you another question. Why are we not all programming in assembly language, for example, or machine language even? Why are we not doing that?
Productivity?
Yeah. There's some human constraints there. It's difficult to read, right?
Yeah.
So there's also the portability aspect. Writing a machine code will only work on a particular machine. But then again, why are we not just all writing in C, for example?
Right. Or Go, like going as high level as possible. The fact that this diversity of language continues, is this actually a failure of our market, or is it actually a normal maturity of it?
Right, but let's park the Go example just for a moment there and talk about C. Why are we not all programming in C? I know some people are programming in C, but we have other languages that have different qualities than C has. And I think one of the thing is that C enables you to do all sorts of things, and it also includes thousands ways where you can shoot yourself in the foot, basically.
If you don't do your own memory management, if you don't do your own threading, all that plumbing code, you're going to hurt yourself.
Right. So one of the things we do is that we say, let's add a constraint that say you no longer get to manage your own memory because there's a garbage collector. And that frees up your mind so that you can think about something else. Mm-hmm, mm-hmm. And I think that's also the reason why we add types, when we have statically typed languages like C# or Java, for example. We add some types because we're saying, now, instead of just thinking about that everything is basically just an integer or a pointer, which is also sort of an integer, right? Now you have types, so you can say, well, this is an object of this type, and this is an object of that type, and so on. So that's actually a constraint as well.
Would you call, I'm having a hard time wrapping my mind around calling a runtime with a garbage collector a constraint. I would think that having to do your own memory management would be the constraint.
But the being able to do your own memory management is a freedom. You can manage the memory exactly how you'd like to do. But I understand why you're saying that, because it's you have a human constraint that so there's this result from cognitive psychology back from the mid 1960s that says you can keep track of about 7 different items in your head.
Yeah.
So if you have to keep track of all the memory that you have to manage as well, that sort of takes up precious space in your very limited, or all of our very limited brains. So pushing that aside and saying, well, there's a machine that deals with that for us actually enables us to think about something that's more important than dealing with the memory. But it is a constraint in the sense that you are now you no longer have the ability to manage the memory yourself. And in most cases it doesn't really matter, but there are a few cases where if you do guidance software for airplanes or rockets or something like that, you need real-time systems, and then you can't just have your garbage collector coming on in a non-deterministic time and just freezing everything up. So it is a constraint in that sense, that there are scenarios where you can't live with that constraint and you need to do something else. But in most cases, like all the enterprise software that we typically tend to write, it doesn't really matter. So
I would consider, just as a programmer, I would consider having a garbage collector as a freedom.
Sure.
Because it's
freedom to not think about some things.
Exactly.
The same for static typing. I need to think about this type once. When I declare it, I don't have to think about it again.
And I think that's what you're getting at. They're freeing constraints that free you or liberate you.
I say constraints liberate, exactly, because they free your mental processing power to do to deal with something that's more important, because you can automate all of that stuff away.
Mark, hang on right there. Hold that thought while we take just a moment for this very important message. Hey, guess what, Rockheads? Progress Telerik wants to send someone to build. So they're having a contest. Step 1 is to sign up and learn about the new innovative modern UI tools they'll be announcing at Build. By registering, you'll be entered to win a full conference pass to Microsoft Build, plus a $500 travel stipend. They're also giving away 3 Telerik DevCraft UI licenses. And for .NET Rocks listeners, They'll also be giving away a Telerik DevCraft UI license every week. All you have to do is register at buildcontest.pwop.me. That's buildcontest.pwop.me. Progress offers the leading platform for developing and deploying mission-critical business applications. The creator of the award-winning Telerik.net and Kendo UI, JavaScript user interface components and controls, reporting solutions, and productivity tools, Progress offers all the tools developers need to build high-performant, modern apps with outstanding UI. Go now to buildcontest.pwop.me and sign up to win. And we're back. It's .NET Rocks. Carl Franklin, Richard Campbell talking to Mark Seemann. Yeah, well, it's a very important thing to be able to be free to think about just the problems that you need to solve rather than having to, deal with the ceremony of this particular language feature or that particular feature. That's why Java and C# exist, right?
Sure, but then you may have noticed that even with languages like Java or C#, all sorts of people have invented all sorts of extra constraints that you can add on top of those things. So you probably heard about, the solid principles, for example.
Sure.
And another one that Bertrand Meyer actually came up with back in the mid-'80s is one called command query separation. It's a design principle for object-oriented design.
Yeah.
And should we just briefly recap what that is?
Yeah, sure.
For sure.
So basically the idea for behind command query separation is that you should separate your methods, the operations, you call those methods in object-oriented design. You should separate them in two groups, and you should say that there's one type of method that is a command that changes the state of your system, and then you have another type of operation that returns some data. And basically the idea from behind command query separation is that you should design your methods so that they are either one or the other, but
right.
They shouldn't do both.
Right.
And the interesting thing here again is that if you look at the C# compiler, for example, it will happily enable you to do something that changes the state of the system and returns some data in the same go, if
Sure.
you will. So command query separation is this extra constraint you put on top of the language, and it may give you some benefits in terms of how easy the code is to reason about, or how easy the code is to read. Once you get into a complicated code base later on. But it's an extra constraint that you can choose to impose on your code base and say, well, in this code base, we will also apply this command query separation principle on top of the rules of the compiler, for example. And if you do that consistently, that will actually impose some benefits on you that then again frees your processing power and enables you to think about some more important stuff.
Yep, absolutely.
That's Eiffel, isn't it? Am I thinking back far enough?
That's absolutely correct. Bertrand Meyer was the inventor of the Eiffel language, and
Right.
and he very specifically designed the Eiffel language around that particular principle. And there's been various people. You can find an article by Martin Fowler, for example, where it says it's a great principle except when it isn't, and it's always like that with the principles. So I'm not saying you should always follow command query separation, but it's an example of a constraint that leads you to a place where things become more principled. And as the design becomes more principled, there's also some things that, because you choose to do it in a particular way and you rule out other design options, a reader can, better understand what the code does, because if he or she understands that this principle is being followed in a particular code base, there's things that shouldn't be, possible.
Right. You're actually removing the possibility that particular classes of bugs will creep up.
In principle, yeah.
Yeah.
Absolutely.
Yeah.
So if you take this to the extreme, you can apply a thing like command query separation and a couple of other principles, and that is actually basically what leads you towards this ideal of object-oriented design that we call encapsulation. This, the idea of encapsulation, if you go back to looking at what Bertrand Meyer says about it, is that there should be some sort of contract around that defines how an object should behave and how you interact with it, and it's the object's responsibility that contract is always, that it always obeys that contract. So again, if you have that constraint where you say, well, we follow things like command query separation, or we adhere to the pre and post conditions that an object states that that's part of the contract, that is again a constraint you as an implementer impose on yourself, but that makes the client developers work much easier to do, because now he or she knows that when dealing with this particular object, there is a set of constraints in place that guides how this whole thing actually works, if that makes sense.
Yeah, absolutely. And of course, I put my data hat on as soon as I think about CQS and think, the locking rules of querying are very different from the locking rules of command. So, those separations make my life easier, more reliable, more scalable.
Yeah, so there's a different thing, and I think we should probably make it absolutely clear that we are not talking. So I know that you're not talking about command query responsibility segregation, CQRS, but that is sort of like an extension that you can take CQS, command query separation, and extend it in that direction, and then you can get an entire scalable architecture out of that. But again, that is a constraint where you impose that, and then you get some benefits from actually imposing that particular constraint, which I think is interesting.
Yeah, again, it's like, generally speaking, we're fighting, our reflex is to fight against constraint. And then when you get completely unconstrained, you're almost paralyzed by choice.
Yeah.
And now, to start thinking in terms of, actually, when I put constraints around me that are intelligent, I'm more productive. I clear a bunch of stuff out of my head that I no longer have to think about to be able to build stuff that people actually need.
Right. So another example so you mentioned Go before, and I'm not an expert in Go at all. I just know that the
neither am
language
I,
exists.
but I was just picking a high-level modern language out of the sky.
Yes, absolutely. But one of the constraints, as far as I understand with Go, is that it is a language that is targeted at being, fairly low level, in the sense that you can write some pretty performant code with it. But instead of working with a threading model, it basically takes the old idea of coroutines, and they call it Go routines, I think, something like that. But it creates a different model of parallelization that is also sort of a constraint, in the sense you can't just do, arbitrary threading.
Right.
You have a very specific model of how you do parallelism or concurrency in that. So I'm hoping that I'm not saying something that is completely wrong here. But that's
the way I've always thought about Go as well.
Yeah.
Is that its focus was on the parallelism side. And it's a very late coming language. I mean, like the late 2000s. Because all the CPUs at the time were parallel. We had multiple cores. Like, that was the norm. I appreciated the idea that, hey, let's start building tools based on the reality that we're in a multi-core world now, and that your reflex, your default behavior of a language should be effective with multiple cores, which is not C was never built that way. And even C#, as much as we love it, predates the commonality of multi-core machines, and the CLR as well. So, I think it's like you've invented a new word for war, start having a different kind of war.
Yeah, so that reminds me. So, Richard, you're doing the history of .NET. I've noticed you talked about that. So I have an old copy, the first edition of the Framework Design Guidelines. You probably know that book as well, by Brad Abrams and Christoph Swalina. And I noticed that so it's annotated by all sorts of people who were took part in the design of the .NET framework originally, and they sort of, some of them come in and say, well, there's this design here, but it's actually not really particularly thread safe. And then they sort of went with that particular design anyway, because even back then, in the start 2000s, threading was not really the main concern
not
there.
At all.
It was so they sort of knew that it could become a problem, but they had other concerns, like just general usability and how easy the language was to pick up, which was much more a concern for them than actually making it thread safe.
Yeah, I mean, in the early 90s when they're working on, or late 90s when they're working on this thing, Microsoft's, for the first time in their existence, inventing their own language. They've always taken other people's languages and implemented them. And they're trying to make something, I've come to appreciate Bill Gates was an object-oriented language believer. And he wanted something very pure in the sense that everything was an object. And that was a push. That was a hard thing to do. But one of the fundamental distinctions between Java and C# in those early days, and one of the reasons that guys like Mad Torgerson and so forth got involved, were the concepts, again, not of parallelism, but of generics, of anonymous types. Java was trying to solve those problems in the late 90s, early aughts, and was struggling with them. And they got a chance to bootstrap that from the very beginning, although they didn't get it into 1. But by 2, they'd laid down really solid foundations around those particular problems. But they're problems we don't think about anymore.
Wasn't it Don Syme that did generics?
Yes, Syme, Eric Meyer, but Anders was involved as well. Mads was brought into Microsoft because he was working on it on Java, and they really liked what way he was thinking about it, and got him involved there. Like all of these folks, it's interesting that the serious thinkers about language at that period were all struggling with this particular issue of the concepts around generics and so forth. Yeah. Even though again you wouldn't really see them manifest until 2005 and ultimately 2008. That was what was on their minds.
Fascinating.
And they needed to set a foundation to make that come true.
Hey, Richard.
Yeah, buddy.
Guess what time it is now?
It must be that happy time again.
Yeah, it's happy, all right. It's time to tell a joke with some interesting constraints. It must include motor oil, dill pickle slices, 2 bananas, and a plucked live chicken. Never mind. That list was funny enough.
Sorry, I was looking at it thinking, you mean Saturday. Okay.
What just went through your mind was hilarious, trust me.
I had hoped for a haiku, though. or at least a limerick. You could have made a limerick.
I didn't have that kind of time.
I couldn't make up a anyway.
Well, it's actually time to give away a DXperience subscription from our friends at DevExpress to one lucky member of the .NET Rocks fan club. You know, everyone knows that DevExpress has great desktop controls, but their web tools are just simply amazing. They have this collection of HTML5 JavaScript controls called DevExtreme. At the heart of the product line are these really powerful controls like grid, chart, pivot grid, tree list, and scheduler. But DevExtreme also comes with more than 50 touch-optimized client-side controls, data visualizers, navigators, editors, lists, dialogues, and notification controls, and general-purpose controls like a filter builder, range slider, file uploader, scroll view, and more. Now, since they're all HTML5 JavaScript CSS, they include integrations with things like jQuery, Knockout, React, Ionic, and Angular. Plus, DevExtreme controls come with ASP.NET MVC and ASP.NET Core wrappers, so they're infinitely flexible. But don't take our word for it. Go for a test drive at dx.netrocks.com. That's dx.netrocks.com.
All right, buddy. Who's our winner?
Today's winner, Richard, is Mark Costello.
Congratulations, Mark. Golf clap for you.
Golf clap for Mark. Mark just won the DXperience subscription, a big pile of awesome from our friends over there at DevExpress, just for being a member of the .NET Rocks fan club. And if you'd like to join, go to .NETRocks.com, click on the big Get Free Stuff button, and answer a few questions and join the fan club. We have thousands of members all over the world. In every show, we like to give away stuff from our sponsors. And every December, we give away a $5,000 technology shopping spree to one lucky member of the fan club, but you got to sign up to win. And we also like to ask our guests, Mark, if you had $5,000 to spend on technology today, what would you buy?
You know, I'd probably take the money and put it, aside for later on to buy a new laptop sooner or later.
Oh, nice.
I'm basically on a 6 years old Lenovo X1 Carbon at the moment, so and that's another constraint.
Yeah.
I think it's actually quite interesting to see, just how old this machine can get and still be workable.
Before it's a laboratory experiment.
It sort of is, but there's a couple of interesting things about it. One of them is that, compared to modern computers, it's starting to get a little bit slow, which means that if you have a slow development computer, you're really forced to do something that is fairly efficient, and you'd also have to make your, the processes and the way you work with things fairly efficient. And another thing is that I've noticed that often when you ask people this question is that they want, bigger monitors. And I've been working with my laptop monitor since, not only with this machine, but also with previous laptops. So I've basically just been programming on laptops since 1999, something like that. And the thing that happens when you only have the laptop monitor is that you're sort of forced to compartmentalize your code in such a way that you can't have that much code on a screen at any given time. So it's sort of, really strongly, suggests to you, if you're writing a method that becomes too long, it becomes very clear that it is too long. I remember. So you had an episode with, I think it was Steve Smith, fairly recently, where he talked about pain-driven development.
Yes,
right.
The idea is that if you're starting to feel pain, you should do something about it. And having a small screen makes it very painful if you have long methods. So you should probably naturally want to do something about that as soon as possible.
Oh, dude, I've solved my long method problem by just getting a bigger monitor.
Yeah, that's the thing. But yeah, I've met lots of other people who have, in my opinion, far too high a pain thresholds. Where sort of like, how can you live with that? That's horrible.
Right.
But I've certainly talked to people who are like, I prefer to develop on my laptop, so I don't get used to a bigger screen. Like that's the way I just work with things.
So that's my preference as well. But now we're talking about Steve Smith's and his episode that you had recently. There was another thing that I was reminded of there. So he talked about clean architecture, and one of the things that he was talking about is how he tends to create various modules. So he has, like, for example, a domain model, and the domain model contains all the interfaces, and then he may have an interface. An infrastructure module, I think he called it, where he has, for example, all his database implementations. And that database implementation implements the interfaces that the domain model defines.
Right.
And he sort of, I think he knew this, but I just think he forgot to tell you. But one of the benefits that this sort of architecture gives you is exactly it imposes a constraint, because by having the interfaces defined in a domain model and then referencing that domain model from your implementation, you have a project reference going from your data access library to your domain model. So if you ever try to add the reference to the data access layer from your domain model, that would give you a circular reference, which, for example, a tool like Visual Studio will not allow you. So that is, again, the reason, I think the underlying reason why people have that sort of architecture is exactly because it does enforce that constraint that you can't have circular references. So by picking, the direction of the references, up front, you now have tooling that enforces that constraint for you, so that you don't get all of those circular references instead.
When I think about the ultimate constraint in programming, I think about functional programming, right?
Mm-hmm.
Because it has so many constraints built into the language, built into the architecture of the languages, that you just, certain things you just can't, it's impossible to do. It's impossible to have a null reference exception.
Exactly. So that depends a little bit on exactly which functional programming language that you pick. But we also did an episode on Haskell a couple of episodes back. Well, last time I was guest. And Haskell actually does have that, those constraints that you can't have null references, for example. Mm. You also can't have, you can't mutate state unless you have very specific, type annotations that enable you to do that anyway. Right. So thinking back to a constraint like command query separation, for example, that Bertrand Meyer's, constraint there, sometimes when I try to teach people, just object-oriented developers to apply the command query separation principle, sometimes they come up with all sorts of examples or counter examples where they say, well, we can't apply command query separation in this particular scenario because blah, 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 blah. And what I always have the experience is that you just need to think about the problem in a different way.
Sure.
And basically what I always tell them is, but you can always apply the command query separation principle to all code. And then people say, but how do you know that? Well, I know that because I know that Haskell is a Turing-complete language, and it's basically all queries. If you look at command query separation, it has made the extreme separation of saying, there are no commands, there are just all queries. So you basically just push the slider all the way towards, saying no commands, all queries, and then you still have a Turing-complete language. So if that's possible, that must mean that, at least at one extreme, you can always apply the command query separation because you just do all queries, and that still works.
So if a query can take an input, and that's what I think of when I think of a command. I think of, we're telling the computer something, we're giving the computer something, we're issuing a statement, we're sending data in. So doesn't a query just become a function if there's no commands and there's just queries? If you can send input into that query, which you have to, it's a query. Doesn't that just become a function?
So the difference between functions and queries is that a query is something that returns data, often based on some input that you give it. And when you're talking about functional programming, the extra constraint you put on a function in order for it to be, a real function, if you will, is that not only must it, be deterministic, so you can't have any sort of randomness going on inside of it, but also you can't change state. So basically what Bertrand Meyer talked about already was that he said queries cannot change the state of the system because that's only for commands to do. Right. So we add the extra constraint when we're talking about functional programming is to say not only can it not change state, but it must also be deterministic. So you can't have any sort of random stuff happening inside of a pure function as they're called.
So if Haskell is only queries and no commands, how does anything ever get saved?
Yeah, isn't that interesting? Well, so they have this little trick called I/O, and basically I/O is you probably heard the word monad, and we should probably not go deeply into that right now. But it's sort of like one of the ways that you can think about what I/O is. It's sort of, you probably heard about Schrödinger's cat, this whole idea from quantum mechanics, where you say you put a cat in a box with some poison, and then there's some random radioactive decay thing that may
50-50 trigger.
Yeah. So maybe the poison kills the cat, and maybe that doesn't happen, and it's truly random because it's based on some sort of radioactive decay, and then you don't know whether the cat is dead or alive. So the one interpretation of I/O is that it's sort of like a box like that. So if you have a function that returns, like say an I/O of int, it's a box that contains an integer, but you don't know which integer it is. It's just like the box with the cat inside of it is a superposition of all possible states in the universe. The I/O of int in Haskell is also, that's one interpretation, is sort of like a superposition of all the possible integers that it could be. And it's only when you sort of look in the box that you actually know which integer it is. But looking into the box makes everything, changes the rules of the game, basically. It makes everything impure. You can only do that if you're already in impure context. That's probably a little bit of a different discussion that our theme right now.
And I still have no idea.
You didn't think there was already quantum computers, and then you met Haskell.
It's just like quantum mechanics. How hard can it be?
How hard can it be?
I did a whole show on quantum mechanics with Rich. I still don't know what the hell we talked about.
Yeah. No, I think that basic quote of, if you think you understand quantum mechanics, you don't understand quantum mechanics.
Yeah, that's right. So, but there's lots of things that constraints are everywhere, and if you design with them, I think we can actually do something that are really interesting. One of the other things that I figured out is that lots of people who are trying to understand dependency injection, I wrote a book about that, quite a few years back. So I often get those questions about how do you do this and how do you do that? And often the question is in context of some sort of dependency injection container. And what I typically tend to tell them is, the dependency injection container doesn't really make it easier for you. It actually makes it harder. So if you give yourself the constraint saying, don't use a dependency injection container when you do dependency injection, things actually will become easier. So again, at a certain level, you can see that as a constraint, saying, well, you should do the dependency injection, but you should do it without a container.
Yeah.
And by imposing that constraint, things actually become easier for you, because one of the things that happens when you do dependency injection with a DI container is, first of all, often people don't really understand exactly how it works. So it's sort of like a magic box that they don't really understand. So by taking away the magic box, you're sort of forced to understand how dependency injection works in principle, instead of it just being some sort of magic thing that's over in the corner. But another thing that also happens is that actually when you use a dependency injection container, what often happens is that you have things that you will often have things that compile, but then when you try to run them, you didn't configure the DI container correctly, and then you get all sorts of runtime errors, because now you get an exception that says, well, you try to get an instance of this interface IFU, but I have no registered component for IFU, so therefore I'm now throwing an exception. Whereas if you don't use a DI container, you actually have to wire things up by hand, and that means that if you didn't do that correctly, the compiler will simply complain and say, well, you didn't compose your object graph correctly, right. So it doesn't compile. Yeah. So now you get faster feedback. So again, imposing that constraint, not using a DI container, actually makes things simpler.
You must have a list of your favorite constraints that you wish all developers could impose on themselves.
Oh, I have plenty. So basically, I really, a lot of the constraints, we already talked about that, but a lot of the constraints actually lead towards functional programming. So this is why I'm really happy about functional programming, because if you take things like command query separation and saying, well, all that mutation is actually something that makes it really, really hard to reason about programming. So if we impose the constraint that we say we can't do uncontrolled arbitrary mutation, then that some things become easier to reason about. So that's one of the things that I think is really useful.
Yeah.
But there's all sorts of interesting things you can do. Another thing is we talked about a little bit about DI containers already, but also what you often see people do with dependency injection is that one of the reasons why they start doing dependency injection is because they want to do some sort of unit testing. And when you use dependency injection, the way that you can use unit testing again is by using those dynamic mocks, like Fake It Easy or MOQ or what are they all called? So they sort of go hand in hand. If you're using dependency injection, you basically also need to do those things. But one of the interesting things about, again, if you start to looking at not having all sorts of non-deterministic behavior in your code and not having arbitrary state mutation in your code, is that when you push your code towards something that is more functional, it also becomes much easier to unit test, because you don't have all of those dependencies. So if you can sort of push the dependencies away, so what functional programmers often talk about is they push the dependencies towards the boundary of the system. So all the business logic, all the domain logic you end up implementing is sort of as free of dependencies as possible. It also becomes much easier to unit test. So again,
Sure.
You could sort of give yourself the constraint and saying, well, maybe I should try to design the system so that I don't need stops and mocks. Mm-hmm. And then it might actually become, the code might actually be better all by itself.
That turned up in our conversation about test-driven development, is that your tendency to write tests first changes the way you implement the code.
Absolutely.
To make it more testable.
Yeah.
So, it's exactly the same thing. You've applied a constraint of I need to write tests. And right away, I don't know. The question is, did you write better code? Or is it just more testable? The implication, of course, is that more testable is better.
So I actually did an experiment of sort of, it's not a really scientific experiment, but like 10 years ago, I started with a greenfield development in a job that I had back then. And I thought, it'd be interesting to see, what does test-driven development actually do if I basically just, do it as it is described. So, write the test first and not really thinking too hard about what happened, but just sort of see where that led me. And what I figured out is that if I sort of switched off my critical thinking and just did TDD, the mechanics of TDD without really, critical thinking, it didn't really lead me in a good direction. So
Right.
I ended up with code that was very testable. I think I probably had like 95 or 100%, code coverage, but the design wasn't nice. Because the process in itself doesn't lead to good design. It's just like a feedback mechanism that, if you think of a design, then you write a test and then you get feedback on whether that design was a good idea or not. And often what happens is that, that test tells you, oh, that design idea was actually not a good idea. And then you go, okay, I need to do something else.
Yeah, right.
But another thing that I've found interesting is that, we talked about that episode 1001 where we talked about flow.
Yes.
And what I've found is that it sometimes actually is flow can actually be dangerous. So another constraint that that I've used the last couple of years is that I deliberately impose breaks in my work. So you may be familiar with this thing called the Pomodoro technique, where you go for 25 minutes and then you have a 5-minute break. And originally I started using the Pomodoro technique because I had, sometimes I had, lots of things that I didn't want to do. So it was just a way to force me to, get the stuff done. But I'm more and more beginning to use the Pomodoro even when I'm programming, because I think every programmer has probably tried this thing where flow is nice sometimes because you're just coding and coding and coding, and 5 hours pass and you sort of feel very productive. But what also often happens is that you get stuck in something where you have this problem and you can't really get out of it, and you're sort of in a rut.
Yep.
And what I found is that, I have this rule with my Pomodoro now that when the break alarm goes off, I have to get out of my chair and I have to leave the room.
Right.
So sometimes I basically just step over my threshold and then go back into my chair. But just the fact that I need to, something happens with your brain when you step over a threshold, when you walk through a door. So this something very, very strange happens that often, it's like it sort of breaks the rut, if you will. So you probably heard about this other idea. There's a process called rubber ducking, where you tell the problem to a rubber duck, or you can also use it.
Yep.
If you don't have a rubber
duck typing, but like, okay, no, I'll tell the problem to a rubber duck.
No, just the act of talking about it brings it to light.
Yeah. So if you don't have a rubber duck, you can also use a colleague, but basically just the act of actually trying to, say out loud what the problem is will often get you to a point where you realize by yourself, oh, that's the problem. This is why I've been stuck for 3 hours. So by imposing a constraint of saying I have to take a break every 25 minutes, I often get out of the rut, within at least 25 minutes. So I don't, waste 3 hours on that, which I might do otherwise.
There's also some really good science behind brain fatigue after 15 to 20 minutes. Mm-hmm. If you're just constantly focused on something for so long, you really do need to just do something else, or think about anything. Like think about Star Trek for 5 or 10 seconds or whatever, just something completely different, and then go back in.
I love walking the dog.
Yeah.
Yep. I get most of my work done when I'm not in front of my computer, actually, and just going for a run or whatever. I get all my good ideas on my bicycle. I'm in Copenhagen. I ride my bicycle all the time.
Writing things down, also making lists and writing things down is a great tool for clarity.
Yeah.
Simple things.
So that's also often what I tell people as well, get away from the computer, because that might be another constraint that you can impose on yourself. They're saying you shouldn't be in front of your computer more than, whatever works for you.
Yeah.
But have a particular limit for that.
I was listening to another podcast, and I think it was about the benefits of waiting. It started with a guy who said that he was an investor at a startup, and these guys were going to start in 6 months, right? They're going to have their website up in 6 months. And this guy gave them a whole bunch of money, and there was never any progress. And it turns out they had spent the whole 6 months thinking about a name for the company. and they hadn't come up with it because, that's a lot. Like branding, is the domain available? Like all these things are really important. And so, 6 months come around and the guy's like, hey man, where's the website? Where's everything? And they're like, well, we're still kind of thinking about it. And he was kind of really mad, And it turns out that it did take them another month or two to get things going. But it also turned out to be like a ridiculously successful company. And from that point on, the guy was like, you know what? Things don't need to happen right away. It's more important that we do things right and take our time than to, just be
quickly.
Speeding around.
Yeah. It's funny how that works out. And I've seen both philosophies, both very viable.
Yeah. I guess it matters who you're investing in, right?
Yeah.
So, Mark, is there anything else that you want to talk about? I mean, it sounds like we could go out for a beer and talk constraints forever. I mean, it sounds like you've got a lot more up your sleeve, but is there anything else that you wanted to bring up?
So I think if people are interested, they can always go and visit my blog and basically find lots of things there. I talk and write about all sorts of things. I have a video series on clean coders that's called Humane Code, which is basically talking about the cognitive constraints that we have. So again, I talked about this result from cognitive psychology that you can only keep track of about 7 different items at a given time. So that is a constraint that we have with our brains, and we sort of need to figure out how to deal with the cognitive constraints when we are writing code, or basically when we're reading code.
Sure.
So if people are interested, they can always go there and watch my video series, which costs money and makes me money. So that's why I talk about that.
Very good. Mark, thanks. It's always enlightening talking to you, and I'm looking forward to seeing you at NDC this year.
Yeah, you too.
All right, and we'll see you next time on .NET Rocks. .NET Rocks is brought to you by Franklin's Net and produced by Pwop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.
Got transmitter banned by the FCC.